morning, everyone. So, today we'll start with chapter 10. Name of the chapter is Light, Reflection, and Refraction. So, today is lesson 1 for this chapter. So, for this lesson, number 1, we'll study about the spherical mirrors. What are the different types of spherical mirrors and what are their definitions? Second, we'll learn about the important terms associated with the spherical mirrors. With the help of the diagrams, we'll understand this point and how to draw the principal focus of concave and the convex mirror. What are their definitions and how we can draw them. So before moving on further, let's assess your prior knowledge. So the answers of these questions you have already done in your junior classes. And I feel before moving on to further today's topic, you must know the answers of these questions. So let me take one by one for you all. So what do you understand by mirror? So mirror is a highly polished, shiny surface on which most of the incident rays which fall on it will be reflected back into the same medium. This is the definition of the mirror. Next one is how we are able to see the objects. We are able to see the objects because when the light falls on the objects they will reflect the light and that reflected light will be entering into our eyes and we are able to see the objects. Similarly, why we cannot see the objects in the dark room? Because in the dark room there is no light and there is no light which is getting reflected from the object and which can enter into our eyes. So we cannot see the objects in the dark room. What are the two laws of reflection? That's an important one. Two laws of reflection are angle of incidence is always equal to angle of reflection. And the second one is incident ray, reflected ray and the normal at the point of incidence should all lie on the same plane. List the properties of the images formed by the plane mirror. So this I want to discuss with you. Let me list the properties of the images formed by the plane mirror. So first one is the image formed is always erect. Next one is the image formed is laterally inverted. I hope this point is clear to you. What do you mean by laterally inverted? Third one is the object and the image, they are of same size. And the fourth one is that the image is at the same distance behind the mirror as the object in front of the mirror. And the fifth and the important one is the image formed is virtual image. That what do you mean by the image formed is virtual image? What is the difference between real image and the virtual image? Real image is the one which can be obtained on the screen. Virtual image is the one which cannot be obtained on the screen. Or in other words, I can say real image is formed when the reflected rays they actually meet at a point, and the virtual image is formed when the reflected rays appear to meet at a point. So this is the basic difference between the real and the virtual image. And the last one is, do the laws of reflection valid for irregular surface also? So yes, the answer is yes. The laws of reflection are valid for irregular surface, whether the surface is regular or the irregular one. But at the point of incidence, angle I must be equal to angle R. So it doesn't matter whether the surface is regular or the irregular one, but the laws of reflection are valid for irregular and the regular surface as well, right? So let's move on to today's topic, spherical mirrors. So what do you mean by spherical mirrors? Spherical mirrors are the ones whose reflecting surface is curved. Now we can compare this with a plane mirror. Plane mirrors are the ones whose reflecting surface is plane. And the spherical mirrors are the ones whose reflecting surface is curved. Now this curved surface, can it be curved inward also? It can be curved outward also. So based on that, spherical mirrors are of two types, concave mirror as well as convex mirror. Concave and convex. So let me draw the diagram for this. Now I am drawing this diagram. This is a spherical mirror because it's the curved one. I can draw the similar diagram for convex also. Again, this is the spherical mirror. Can you make out the difference between the two, concave and the convex? Right now, we cannot make out the difference between the concave and the convex mirror unless I am not specifying which one is a reflecting surface and which one is a non-reflecting surface. In case of concave mirror, there are two surfaces curved inward and curved outward. So the surface which is curved outward, I am making this as a non-reflecting surface. Now the reflecting surface is curved inward. So this type of mirror is known as the concave mirror, and convex, in case of convex mirror, the reflecting surface is curved outward. So this is the reflecting surface and I am putting the dashes on the non-reflecting surface. Now you can see the reflecting surface is outward. So what is the other way to learn that which one is concave mirror and which one is convex mirror? In case of concave mirror, the reflecting surface makes the cave, that means inward, makes the cave. So whenever the reflecting surface makes the cave, this is concave mirror. And another one is the convex mirror. So if I want to define concave and the convex mirror, I can say concave mirrors are the ones whose reflecting surface is curved inward. Reflecting surface is curved inward. Similarly, we can define convex mirror also. Convex mirrors are the ones whose reflecting surface is curved outward. Right? So these are the two types of spherical mirrors, concave and the convex. So again, just to remind you that don't forget to put the dashes on the non-reflecting surface. So next move on to important terms related to spherical mirrors. So first we'll consider the concave mirror. Concave mirror. So first we need to understand that every spherical mirror, suppose I am drawing a spherical mirror here, this is the spherical mirror, and every spherical mirror is a part of a hollow sphere. So I am completing this hollow sphere. So let me write down this for you that every spherical mirror, this is the spherical mirror, every spherical mirror is a part of hollow sphere. So you might be thinking that what do you mean by the hollow sphere here? So hollow sphere, suppose consider a three-dimensional structure. Suppose you can consider a ball, a plastic hollow ball, and you want to make a spherical mirror out of that, and you are cutting it from a side, not from the mid, but from the side. Now you'll get a small curved surface, right? And if suppose the surface which is curved outward, you are making it as a non-reflecting one, and which is curved inward, you are making it as a reflecting surface. So you will get a concave mirror here. As the diagram I have given it to you, suppose this is solid line and this portion you are cutting from a hollow sphere. And I'm completing the hollow sphere with the dotted line since it's a two-dimensional structure. So it is simply, you can see it as a circle. But if you consider a three-dimensional structure, so it will be a hollow sphere, right? So if you want to make this as a concave mirror, so you have to make this outward surface as a non-reflecting one. So now this inward surface is the reflecting one. So this is representing your concave mirror, right? So I hope I'm clear with this part that why I'm saying that every spherical mirror is a part of the hollow sphere. Now that hollow sphere definitely has its own center, and this center is known as the center of curvature. This center is known as the center of curvature. So what is C here? C, capital C. This capital C is known as center of curvature. This is the center of the hollow sphere from where you are cutting your or you are getting your concave or the convex mirror, right? So this C, which is known as the center of curvature, is the center of the hollow sphere of which the spherical mirror is a part. Next important term here is now about one more thing about center of curvature, as it is clear from the diagram as well that this center of curvature is not the part of the reflecting surface, not the part of the spherical mirror. It is outside the spherical mirror, right? Now this this one and this is reflecting surface, the length of the reflecting surface, as you can see, the solid line is only the spherical mirror. So the total length of the spherical mirror is known as aperture, and it is generally represented by M dash. That means I'm placing M and M dash here. So this is the total length of the reflecting surface, which is known as aperture. Right? Next one is the center of this reflecting surface. So this is the center. The center of this reflecting surface is known as pole. So which is represented by capital P. So pole is the center of the reflecting surface. Right? Next, if I join this point P and C, this P and C will give you radius of curvature, which is represented by capital R. This is known as radius of curvature. So again, if I want to define radius of curvature is again the radius of the hollow sphere of which the spherical mirror is a part. And similarly, as you have done for center of curvature, you can see for radius of curvature is also not the part of the reflecting surface. Now the center of this radius of curvature, this is the center, and the center of this radius of curvature is known as the principal focus, which is represented by capital F. So this is known as principal focus. And the last term here is the distance between P and R. This distance, this is the distance, and this distance is known as focal length, which is represented by small f. So this is known as the focal length of the spherical mirror. So in this case, we are doing for concave mirror. Now there is a relation between focal length and the radius of curvature. That radius of curvature is twice of the focal length. So you can use this while doing your numericals. Those terms can be understood for convex mirror as well. So here I'm writing here for convex mirror. So let's draw the diagram for convex mirror also. So as I have already discussed with you that every spherical mirror is a part of a hollow sphere. So in this case, suppose I am making a convex mirror here also. and I'm completing the hollow sphere of which the spherical mirror is the part. Now I want to make this as the convex mirror. So outward surface will be the reflecting surface. So this is the outward surface and this is the reflecting surface, right? So let's discuss all those terms here also. So C is the center of the hollow sphere of which the spherical mirror is the part. So C here is center of curvature. Now as you can see, there is a difference between the center of curvature for concave and the convex mirror. In case of concave mirror, it was in front of the reflecting surface. But in case of convex mirror, you can see it is behind the reflecting surface, right? So as you can see here, in this case, the center of curvature is in front of the reflecting surface. But if we'll look for the convex mirror, in case of convex mirror, center of curvature, it is behind the reflecting surface, or simply we can say behind the mirror. So now, next we are learning about the reflecting surface. Total length of the reflecting surface, that is known as aperture, which is represented by M and M dash. So here I'm writing as we have done in case of concave mirror, mm dash is your aperture. Now this aperture has its center, which is known as pole, which is represented by capital P. So it is pole. Now if I'll join P and C, this will give you radius of curvature. So R here is radius of curvature. So you can see radius of curvature, whether it's radius of curvature, whether it's center of curvature, or whether it's principal focus. So the midpoint of P and C is known as the principal focus, or in case of convex mirror, they are lying behind the mirror. So this is known as the principal focus. Now next one is, the last one is the distance between P and F. The distance between P and F is represented by small f. So this is the distance between P and F. This is known as the focal length. Now the relation between focal length and the radius of curvature lies here also. So simply we can say 2f will be equal to radius of curvature, right? So this is the relation between focal length and the radius of curvature. Right? So these are the important terms which are associated, which are related to the spherical mirrors. Now these are the definitions for these terms. Center of curvature is the center of the curvature of a spherical mirror of which the hollow sphere is the part. Radius of curvature is the radius of curvature of a spherical mirror of which the hollow sphere is the part. Pole, we know it's the center of the reflecting surface. Principal axis and the aperture. Aperture is the total length of the reflecting surface. So principal axis. We lift the principal axis. So what is principal axis? So here is a diagram for concave mirror. So let me draw the principal axis for you. Principal axis here is, if I'll increase this radius of curvature, so principal axis is an imaginary line joining P and C. So this is your principal axis. You can see principal axis. It's an imaginary line. Since it's a line, you can increase it further. So what is the difference between radius of curvature and principal axis? Radius of curvature has the fixed length. It's a distance between pole and the center of curvature. But the principal axis, it does not have any fixed length. It's an imaginary line with the line joining pole and the center of curvature. So similarly, we can draw the principal axis in case of convex mirror also. So the line joining P and C is known as the principal axis, right? So here this is principal axis, right? So these are the important terms and the definitions. Okay, let's see how to draw principal focus of concave mirror. So first we need to draw a concave mirror. So this is concave mirror. And as I have told you, we need to distinguish between the reflecting and the non-reflecting surface. So I am putting the dashes on the non-reflecting surface, and it is curved inward, and inward surface is the reflecting one. That's why we are seeing this as the concave mirror. Now we need to draw here principal axis. So principal axis should be at the center of the aperture. What is aperture here? Aperture is the total length of the reflecting surface. So let's see, this is the center, and I am drawing the principal axis on this. Now this principal axis is an imaginary line which can be drawn backward as well. So I am drawing it in the backward direction as well. And the center of the reflecting surface, this point is known as pole, and this point, let it be C. This point is center of curvature, right? So now we consider that in order to find out where is the principal focus of concave mirror, we need to take an object which is placed at infinity. So I am placing one object which is at infinity here. Now this is the object which is placed at infinity. Now the incident rays are coming from this point. Okay, so these incident rays, since the incident rays are coming from infinity, that's why we have to show that the rays are coming from infinity. So starting from this object, we need to show the incident rays dotted one. Right? If I'll draw it a solid line, then in that case, it will show that the distance between the object and the mirror has finite distance between them. But we want to show that the object is placed at infinity. So we are starting with the incident rays, we are starting with the dotted line, right? So this is the incident ray, and we need to put the arrow on this to show that the rays are coming towards the mirror. So after striking the mirror, the ray will pass through a point which is on the principal axis. Now we need to draw another incident ray also, because we need, later on you will study in this chapter, that to form an image we need at least the intersection of at least two reflected rays. So here I am drawing the second incident ray using different pens, so it will be clear to all of you. So again we need to take the dashes, and then we can draw with a solid line, right? Now after striking the mirror, it will be reflected back, and again it will meet at the same point as the previous reflected ray on the principal axis. So simply I can say, now I need to put the arrow here. So simply I can say this, where the reflected ray, these reflected rays meet, this point is known as the principal focus, which is represented by capital F, right? So this capital F, this point is known as the principal focus of concave mirror. As you all can see, principal focus is also, as we have done for center of curvature, radius of curvature, principal focus for concave mirror is in front of the reflecting surface, right? So how we can define the principal focus of concave mirror? That the incident rays which are parallel to the principal axis, as you can see, these incident rays are parallel to the principal axis. So the incident rays which are parallel to the principal axis, after reflection from the mirror, all the rays will converge at a point on the principal axis, and this point is known as the principal focus, right? So if I need to write down the definition for principal focus, then there should be the definition for that. So the definition for the principal focus of concave mirror is incident rays which are parallel to the principal axis after reflection from concave mirror will converge at a point on the principal axis, and this point is known as the principal focus. So this is how we can define principal focus of concave mirror. So for convex mirror, since it is curved outward, so I am making it this side. This is the non-reflecting surface, and this one is the reflecting surface, so it's a convex mirror. Now we have to draw here principal axis at the midpoint of the aperture. So draw the principal axis here, since again principal axis is an imaginary line, so I can increase it both the sides, right? So this point is known as P here, and since the center of curvature here is in the backward direction at the back side of the reflecting surface, so this I am seeing this as the center of curvature. Fine. So this is the object which is at infinity. I am putting arrow here to indicate that I am placing the object erect. So this is the first incident ray. Let's put arrow here. So after hitting the reflecting surface of the convex mirror, it will direct in such a direction that if I take it in the backward direction, it will pass through a point on the principal axis, right? Now you need to take care while drawing this, that this line should be the straight one. There should not be any bending here, right? So let me draw another incident ray for you with a different color so that you can distinguish. So after striking the mirror, it will go in such a direction that if I take it backward, it will meet at the same point as the previous reflecting ray. So this point is known as the principal focus. So as you all can see, in case of convex mirror, principal focus as the similar case for center of curvature. So center of curvature, principal focus, they all lie behind the reflecting surface of convex mirror. So how we can define the principal focus of convex mirror? That the incident rays which are parallel to the principal axis after reflection from the concave mirror, they appear to diverge from a point behind the mirror. So this point is known as the principal focus. So let's define principal focus. So how we can define this? Incident rays that are parallel to the principal axis after reflection from convex mirror appear to diverge from a point behind the mirror, and this point is called the principal focus of convex mirror, right? And since they appear to diverge from a point, that's why this mirror is known as the diverging mirror. Diverging mirror, right? And similarly, we can say concave mirror is said to be the converging mirror, right? This is known as converging mirror because here incident rays after reflection they converge at a point. So this is known as the converging mirror, right? Why does a paper catch fire if a concave mirror is used to focus sunlight, right? So this is again, let's move on to this the slide in which we have drawn the diagram for principal focus for concave mirror. In this case, you can see, so this is the general activity. This you have already done, I think, in junior classes in class 6 or 7. that if I place a concave mirror in front of the sunlight, and if I somehow I can place the paper at the principal focus, I can adjust it. After some time, the paper will be very hot, and if I'll keep it further, then it will start burning. So, why it is so? Because we are concentrating the parallel rays at a single point. We are concentrating here at a single point. So, all of the rays are concentrating at the principal focus. So, that's why a paper catch fire if a concave mirror is used to focus the sunlight. So next one is draw a ray diagram to show the principal focus of concave mirror. This we have already done. Match the following. That will be interesting one. Center of hollow sphere of which the spherical mirror is a part. So out of this you can see what is the center of the hollow sphere. So it is your center of curvature. Center of the reflecting surface, that means center of the aperture. So it is your pole, right? Converging mirror. Converging mirror is your concave mirror. Diverging mirror is your convex mirror. Total length of the reflecting surface, that is aperture. Right? So this is all about your today's lesson 1. In my next video, in the next class, so in the next class we'll learn more about the rules and the image formation by concave mirror. Thank you so much everyone.